I welcome all the participants to the second session of day 8. So we have Professor Chandrashekar JSR from NIT Raipur. So he will discuss about effective fog and edge computing based intelligent healthcare system using machine learning. So before sir will start the session, let me introduce him to this audience. So, Dr. Chandrashekar working as an assistant professor in the Department of IT at NIT Raipur. He received his PhD in computer science and MTech in AI from School of Computer and Information Science, University of Hyderabad. He did his B in IT from Osmania University, Hyderabad. He has published several research articles in reputed journals, including IEEE Transaction on Service Computing, Future Generation Computer System, SWAL, and Evolutionary Computation, and Conference Proceedings of International Report. His current research interests include cloud and fog computing, blockchain technology, energy informatics, and artificial intelligence. He has conducted national level workshops of worth 9 lakh funded by DST. He is working on funding project worth of 28 lakh from SCRB, 54 lakh from NMICPS DST, RS 25 lakh funded by NMICPS DST, and 1.14 crore funded by SEED DST. He is guiding various undergraduate and postgraduate projects in the field of blockchain technology, cloud and fog computing, deep learning, machine learning for various real-time applications. He is serving as a reviewer and TPC member of IEEE Transaction, Elsevier, Springer Journals and Conference. He was included in the world ranking of top 2% scientists as per the survey conducted by Stanford University, US and Elsevier on 2023. He worked in various deep learning and machine learning models, which involved the development of nonlinear models, machine learning algorithms, development of DSS, managing database, MS Access and MySQL. The co-chief investigator has ample experience in working with Python, SAS, and R for implementing algorithms in handling skewed data distribution and deploying the machine learning model on the web using Django framework software. He also has a good experience in conducting field survey and impact studies. He has also sufficient experience in working on image data, implemented various machine learning algorithms such as C4.5, SVM, naive-Bayes algorithm, K-means. Also worked with deep learning models such as CNN, RNN using TensorFlow to analyze the image and video data. He has also experience in image and video analysis and AI/ML techniques with aid of in implementing and executing all the activities proposed on the various projects. So with this introduction, I request Professor Chandrashekar to start the session. Sir, please.
Thank you so much, sir. Thank you so much for giving this opportunity to share. I'm audible, I hope.
Yes, sir, you
Yes,
are
sir.
audible.
Yeah, thank you. So, yeah, in this session, I want to uh, discuss about how these the different fog edge and then the machine learning models and how we can compute the nowadays everyone is talking and more computing area, it has several applications. Okay, the application, whatever the application I'm talking about, these all are real-time applications. So far, I am working on it. Okay, so thank you so much, sir, for this opportunity. So I hope everyone is graduated and post-graduated and doctoral means PhD scholars, research scholars. So it may be useful for how things are integrated from the transformation from the fog, edge, and then IoT, then for machine learning. Then also I want to introduce some part of blockchain, how we can use the blockchain on fog and edge computing. People are only knows fog is a different way and machine learning is different way and Edge, then IoT, and then different area blockchain. But I want to summarize of these different areas in this presentation. Okay, so come to the cloud. Everyone is know about a cloud. Cloud is located in different away from our side. So based on the our demand, for example, take a one simple example of banks or some organization. They want to store their data in cloud storage, right? So where they can see nowadays the huge amount of data is generated, and that data should be should be stored as a minerals, and we want to utilize that resources. Okay, so based on our requirement, you just simply pay some amount and you can utilize. For example, banks are having different utilities for their requirement. Okay, so if they want to establish their own cloud or their own infrastructure, we need to provide, or banks need to provide the spend lot of amount. They need to provide the security. They need to provide the different aspects. So they simply they can hide some day cloud, and they can pay for some amount and you can utilize. So here. Simply pay as you go with different applications. So come to the different levels. We have a in a cloud, we have a SaaS, different model means platforms, software as a service, platform as a service, infrastructure as a service. Okay, so we have a infrastructure infrastructure as a service. In infrastructure as a service, we have a different role, the things that is virtual machines, server, storage, then platforms. They my end user to the cloud. Okay, we need some platform to communicate with the cloud. Okay, that's why we are using the databases, web services, web servers, and deployment tools. Then software as a service. We have some software as a services. Very recently, high performance computing is deployed in one of the IIT. So what happened? This cloud, we know only how much of data you wants to store in the cloud, and you just pay and you store. But here, what happened in HPC? What they are doing is they are allocated. For example, we have 100 GB of data, so that 100 GB of data is distributed to 1,000 students. For example, NIT Warangal. NIT Warangal, around 5,000 students are there. So 5,000 students needs to access the cloud environment. So how it is possible? So it's a very challenging. So they are creating some different for 10 GB of data to one student, 20 GB of data one student, likewise. And then same time, how much of data is utilized, or means how much of cloud is utilized by this particular that should be visible virtually. I mean, so everything is visible. So likewise, software as a service. How much of data is utilized, how much cloud is utilized, and how much of cloud is given to others. All this information has been given in the software as a service. So let's see why people are going toward the edge. Means first of all, you can see the latency problem. Okay, so in latency, for example, you are open a YouTube, okay, and you are running one program or any speech or any lecture. Okay, so there you can find out below there is a line, and while that line should be covered, like some 5 minutes, within 10 seconds, it will be filled with some information. Then you can after 5 minutes again some information will be um, given. Then accordingly, beside that, that video will be running. Okay, so whatever the video you are watching, that video will be run. So there is a good example for video streaming. So there will be a nothing like there should not be a latency problem in that. So then gaming, people are students or anyone, means people are kids are playing the games. So there is a some streaming platform. So that the that streaming is extracted from the cloud. So they be regularly all the sequence way, all the information. Then geographical distribution, so which is a distributed means distributed deployment. So data will be distributed among the across the world. So from there we can extract the information. So that is one. Then mobile development, nodes will be moved. So mobiles like see, we are moving the mobile here and there. So you want to see some videos and all. So there will be a some there should be a some information should be extract from the cloud. And we have a sensor nodes. So with the main problem with this I mean cloud and edge computing, people are talking about the latency and security aspects also. So here in limitations of cloud computing is first of all is always connected. That is the cloud is not always connected. So the connectivity to the cloud is a prerequisite of the cloud computing, and the IoT system need to work on everywhere and anytime. So all the data. And next one is the bandwidth. For the cloud, we need a proper bandwidth, so that only we can access the information from the cloud. And the third one is centralized analytics. So during the analytics part, we always extracting the information from the cloud and applying different machine learning model or XYD, XYZ and machine learning. So and next one is short. Okay, for example, you are storing your data into the cloud. We need to provide the data security mechanism. Whether the data is stored in the cloud, and when you are extracting the data, then you need to provide the encryption properties and all. So the encryption and decryption properties should be provided in to the cloud, to the data when it is sending to the cloud. So fog, you can see from here we have end devices. End devices is a collection of mobile phone or wrist watches or smart home appliances, IOV, Internet of Vehicles. Okay, then different end devices we have. So these all devices are connected with the fog devices, and these fog devices is connected with the cloud. So whatever the data you are frequently using, that data is stored in the fog devices, and to reduce the low latency. So then you can work on different platform. You can work on different applications and extract the information into. So you can see here, this is a white paper. So here from cloud to fog, fog to edge. So we have a cloud computing where we can do software as a service. Then we have a come to the we pooling. So we can for example, we have a five different slices or storage capacities, five 10 10 10 10. Okay, and the people are not, we have a five storage capacities, and the people are not utilizing this particular out of five, people are not utilizing one capacity, then it will be said that information means that storage capacity is said to next user. So likewise, we have a infrastructure as a service, platform as a service. And in fog computing, it's a very near to the end user. As well, we can do the secure multi cloud in internet working, and we have a federation, fog federation. We can do analytics part. Then you can see the edge computing. It is a combination of a device management. We have a various end devices, right? So then we have a data service communication, and then we have different embedded applications of operating system. So see here, these all like the Internet of Vehicles. So these all vehicles are connected with the edge cloud. We can say fog. Okay. So whatever the it's an autonomous vehicle. Of vehicles are communicated will be happen that immediately the information is sent to the ultra fast radio interface, and from that it will be reached to the edge cloud, edge computing, and then from there we have a central cloud where we can give the path planning, where can and where we have a traffic management. Okay, so these all are stored in a central cloud, and we have a edge and connected vehicles. So these are the different layers we have for the fog computing. Okay, so you can see here, first of all, in PPT, we have a application. Okay, so in application, we have IoT we can utilize. Then we have a wireless sensor network, and we have a autonomous vehicles, and we have a traffic network. So it is a application layer. Then we have a security layer in fog. So that is encryption, decryption, and privacy authentication. And then we have a resource management. So in resource management, we have a various entities. Here we have a first entity is resource allocation, okay, and scheduling, then energy saving, reliability, and scalability. So let's see about resource management. So uh, fog scheduling. You particular knows about cloud scheduling problems, fog scheduling problems you can do. Then then you can do the edge computing problem. You can also work on scheduling problem and resource allocations. Various resources are there. For example, we have a physical mission, and each physical missions we have a various virtual missions. Okay, so these different virtual missions are running in one physical machine. Likewise, we have a n number of physical missions. So here, one different applications on running on virtual machines. So these are virtual machines running. So in some cases, if one virtual machine is failed, or some machines are not working, then the data, remaining data, will be sent to the other resources. Okay, just a minute. Okay. So, sorry. So next one we have a energy saving. Energy saving in the sense, let's see one very good example for energy saving. That see this Facebook. Okay, social network. If you consider the say Facebook, when it is started, so it's a small scale of data center is started. Okay, so see, now whenever you are feeding some information or the some data on the Facebook, where it is stored, it's stored in the data center where the all the means back end of the Facebook. So this data is stored in the data center. Okay, so we start with a very small data center. Later on, when the huge amount of data is generated, so these all data means this data center also increased in a means a large scale. Okay, so in computers, if you see the systems or workstations always is producing the heat, right? So to overcome of that heat, the Facebook some kind of this some industries or deep their data center in the sea, right? Means the data center, these systems are required sea. Okay, cooling, so that this will be not be means the system will not be fail. So this means people are working on energy saving system also, energy efficient model. Then come to the storage, data backup and storage virtualization, where we can store the information, and you can see the pre and post processing. Once the data is stored, then we can analyze the data, then data filtering will be done, then data flow, data timing, trimming and data reconstruction will be done in pre and post processing. So here we can use the machine learning models or AI models for construction of data or filtering of data. Then monitoring, system monitoring, then resource demand, performance prediction. So these are the area where we can, this is the layer where we can monitor the entire system. Okay, how the end user means the people cannot be see the cloud. So based on the software as a service, they can monitor which system is working on, which system now is not working, which system is dead. So the all the information will be seen in monitoring system. Then we have a fog device and server and gateways. This is a device configuration storage. This will be here in fog devices. Then we have a physical layer. In physical layer, we have a physical sensor, virtual sensors, where we can extract, deploy into the real-time area, real-time information from the sensor. From the sensor, be sent to the device this fog devices gateway. From fog devices gateway, it will be sent to the monitoring area. Then after that, we can send it to the pre-processing, where we can do the machine learning or prediction, whatever. Then storage and all. Okay, so these are the different characteristics helps for computing, that is low latency, and that is video delivery, navigation information, then location awareness. Then we have a widespread geographical distribution, mobility for fitness tracker and mobile and vehicles. So here we can see the system 75% of system is cool. Okay, then we have a different drivers here, that is low latency at real-time response, which device will wants real-time response for the content delivery and actionable information. And we have a dynamic number of nodes in the fog, that is a number of device within the fog is dynamic. Okay, where we can have a different type of fog nodes, and we have a high mobile nodes, so where nodes will be entered and exist a fog and must be adapted and continue the performance. And then we have a diverse set of failure modes. Okay, and then we have a security, you can the access for you. So you can see the Netflix use this fog area from the, you can see the things. Okay, then these are the top videos are used for computing, where we can have a streaming, Netflix and HTTP media stream, raw, Amazon Prime, YouTube. These are the top American, the Americans, and then top four YouTube and this, or and then we have a Netflix, Facebook and HTTP media top three. Okay, so the okay, you can see different countries are using different software, means this one. Then we have a this is the how Netflix is streaming works today. Based on we have a consumer electronics, we have a cloud, AWS cloud. Then we have a distributed edge locations in data centers, and then from there we can have a different APIs. From APIs we can extract the information. Okay. Then come to the edge. It's a push of application data computing and edge of internet, close areas, that is sensor devices and end users can see. So one of the example for this Akamai, where with the servers around the distributed website content from the close end user. So these are the key features of fog and computing, where we have different components that we have app hosting. Key features is it will be good at fog, but there will be some limited in edge computing. Then we have a data service edge. In both cases, it is available, and then we have a data and app management. In both cases, we have. So likewise, you can see real-time control, high availability is and good at fog and not good at edge computing area. So these are the difference between fog and traditional edge. So edge computing awareness of device and few services, unaware of entire domain in edge computing. But in fog, it is a device independent and is very intelligent and it aware of entire fog system. Okay, so similarly, if you see the limit in edge, it's a limited control in edge domain, whereas for computing have its control on all the devices in the domain. Then in edge, it is having cloud and away, and then in the fog, it extends to the cloud as a consortium, and then we have a limited scope here, and we have a good complete network scope here in fog. You can see in if you see in terms of security, uh, the security scope is limited in edge computing, and here we have a end-to-end in the for computing environment. So, we have a latency, then we have a bandwidth good at, and connectivity is good, and then and local dependencies or the here. Then we you can see this is a teleco view. So the this teleco you can have you can see here we have a different video analytics and then augmented reality that these are interacted or connected with the edge nodes, and these edge nodes are connected with the operator network. Then it is connected with the internet. So the main fact for this coming to the edge computing is reduce the latency to through the edge computing for this example. So here you can see the IoT edge to cloud. So we have a sensors here, and then it's connected with the edge where we can do the basic analysis. It's like a LAN or WAN, and we can do the resources and then data visualization. We can do in edge. We can do the data analytics, data catching. Okay, so these are also good research areas: data catching, data visualization, then data optimization, and machine concern. So these are good research area. And come to the cloud, we can do big data processing, business logic, and data warehousing part you can work on. So this is one example that means we have a different examples for fog, the edge computing, face recognition is very good, and application then we have a face recognition, then speech recognition, then we have image processing and data quality assessment we can do here. Okay, these are good example for fog and so how these are connected and fetching the filtering the data. So you can see here we have a mobile devices. From mobile devices, all the information sent to the end devices, and from that it will be sent to the cloud. So this is a so I'm movie. So let's see this example how the common architecture for IoT application. Okay, so here you can see the one of application that we have a sensor nodes here, and in the sensor nodes, and we have a activator nodes. Okay, and then from there we have a local monitoring system, and these sensor nodes and actuator nodes are controlled by control nodes, and we are connected this control node or fog, and then from there we can connect the cloud services. Okay, so here is a local processing and executing of different examples. Okay, then you can see here remote monitoring of entire system, and then people will take care of data analytics where we can take the decision which one is a good one. So let's see the good exam here. So we have a different components here. So this components are connected, and sensor nodes sends the data to the controller nodes or directly to the cloud nodes. So the control, what the role of controller nodes? Controller nodes are collect the data from the sensors and apply some business logic on its requirement, and then it sends to the fog area, fog computing, and then they will be work on. So what is the role of how this controller is work on? The controller nodes should be connected with the this one various this fog nodes, and these are connected. So these are the computing. You can see real data processing will be done, and data catching, buffering, optimization, mission to mission work on you can do, and cloud and data centers are connected because these are the end devices which are connected with the different platforms. So this is house autonomous is like a autonomous house. This team is take care of all the processing things. Okay, so by using sensors, by using MQTT or COAP, we are sending the data to the cloud. Okay, and we can access. So this is a simple one. Then it comes to the healthcare sector. How the healthcare sector is adapted IoT as well as for edge computing. So you can see here where we have a different different doctors, patients, and nurses are there. They are located in different areas. Okay, and you can see patient with a doctor, and here patients checking their physical or mental status, and this here you can see the means medicines, and it is a registry area. So here, healthcare provide the medical services for maintaining and improving the health by using various preventions, diagnosis, treatment, and then recovery or cure of different diseases, illness, injury, and physical and mental harms in the working. See, the importance of IoT, patients can have a different IoT sensing devices, and people have there is some application, and we have a data center, and we have a cloud. Okay, local computer or fog computer, and there will be a doctor. Doctor will be interact with the patient through the app, and they will monitor the condition, and they will give the prescription for the this patient. So we have done some work likewise in this area. Okay, So here you can see remote monitoring of patient's health in reducing the length of hospital stay and prevents of readmissions. So based on the condition of the patient, they can accommodate in the hospital. Otherwise, they can simply give the this one. So here we can use different sensors. So these are some example of sensors. So we have a heartbeat sensor, oxygen level sensor, glucose level sensors, and then we have a temperature, and we have a pulse rate, we have a position sensor, we have a motion sensor, we have a hydration sensors, and we have a gas sensors. Like different sensors we have, and we have a MCU controller, Arduino UNO with Wi-Fi, and these are the different controller where we can gather the information from the patient, and we will send it to the cloud, and we can have a some different machine learning or uh, like optimization whatever, so we can predict and we'll send the information to the doctor, and based on that, so this is the architecture for that. So we have a different sensors. These entire sensors are controlled by the control nodes, and then it's connected with the fog computer, and in fog by using Wi-Fi or LAN you can connect it, and then we have a local caretaker monitoring of this entire system. So we have a some people for looking after this, and it's into the cloud services, and from there we can monitor, and we can see here patient family remote care taking monitor, that will be done by doctors and nurses, and we have a big means data decision making. So COVID season, this type of models are very much utilized, and people are work on this type of models, and they help to the COVID aspirants during the COVID period. So these are the devices. So from the this controller collect information through sensors, and we have a different sensing devices, and they will send to the cloud. There we can have a machine learning model and all. So these are the how the devices work. So device execute some business logic and analysis on collected data, and send the filter limited data to the cloud computing platform. Okay, and same time we will send the alert messages to the caretaker if the means whether it is positive or negative of any diseases. Based on that, they will give the prescription. So this is one of the good example we have done. Real-time example we have done. We have developed a product, I mean, so develop a device that is effective monitoring and prediction of Parkinson disease in the smart cities using intelligent healthcare system. So Parkinson disease is one of the survey neurological disease prevent in the world across the 5 million people are facing problem with this Parkinson disease. Okay, and this neurodegenerative disease is impair the body balance, damage the motor skills, and leads to the disorder in the speech speech production. Okay, so most of the people are mostly familiar with the motor symptoms of the Parkinson disease. So however, the increasing amount of research is done to predict the Parkinson disease from non-motor symptoms that resume the motor. So early reliable is the most important and possible the patient to get the proper treatment at the right time. So the non-motor symptoms consider the rapid eye movement, sleeping behavior disorder, and olfactory system. So we develop a machine learning model that can be help us in predict the disease can play important role in the early detection and early prediction of the this Parkinson disease. Once we gather the information, we have done the data imbalancing of the this gathered information. So this is a we have a end users and we have a edge devices in a billions and fog nodes we have and this cloud data centers are there. So there are several modules in this framework, that is a smart region, smart devices that equipment by the different sensor which capture the voice signal. Okay, so let's see in a COVID period. Okay, we have a different symptoms, right? Fever, then cough, then cold, okay, and even cough. We have a different type of cough, right? Dry cough, wet cough, and people are talking about different type of coughs. Okay, and predict how we predict, and this particular cough is not relevant to the this COVID-19 COVID-19 um, effect. Okay, so we used different voice signals, and based on the voice signals, we have captured and we have done the this modeling in by using MicroPython, and then we have sent to the cloud, and we have done analysis part in the cloud platform, and then we'll have a, you can see next one. So in end user, your patient live in smart region which is having many sensing devices and edge devices, but we have only interested in those sensors and devices. We can record the or catch the voice signal which is through the mobile phone or portable computer or voice recorder or some devices. Okay, so the second, the first step, end user register with their services provided over the front end, like mobile application and all. Then second step, they will send the recording and sensing devices can different criteria, different information data. Okay, that heartbeat, and we have a pulse, we have a pulse and BP, whatever. So these all the data will be sent, the virus, the cough or whatever. This will be sent to the through the mobile app is uploaded, and then it will be sent to the cloud fog, and then we have done some analysis part, and then we will send it whether the system, you can see this is the entire system. So we have a patients and we have a different managers which helps to work on for this client patient, critical patient and a cloud. Then we have used fog bus workers, and then we have a use a machine learning model, exaboost model, which helps us uh, running of parallel components, parallel data in a cloud, and it gives us a good prediction spot, and then we have send the information to the doctor whether this particular person is affected or not. So based on that, if he is affected, then immediately they will send to the hospital, or some prescription has been given to the end user. Okay, and that is one of the example how the fog and cloud AI plays important role. So this is one of the very good. Means this is also one of the example. Already we are working on it. Okay, I will show the app for this. This spectrum, autism spectrum for community. Okay, rural community, because this community is facing problem here. So this autism spectrum disorder, as describe the challenges associated with the communication, that is the verbal or non-verbal and the social skills and the repeated behaviors. So we are facing lot of problem here, this community, these rural communities. So due to their resources of screening, diagnosis, treatment, services for individual with ASD. So firstly, the screening of ASD is done manually with the help of questionnaires. Questionnaires are there. So when they are approaching to the doctors, they are taking the hard copy and they are filling things, and then it will be provided to the doctors and special educator. However, these methods are time consuming and might be miss the critical challenging problems. So what we have done is we have developed a mobile application, and based on the video analysis, okay, we have taken the video of the patient as well as the devices through the relevant information. Okay, so this data is sent to the uh, uh, fog devices, and then cloud. Then we are applying different models, feature extraction, and then we are predicted this person is not uh, affected with the ISD or not. It's a pre-prediction, okay, pre-prediction, early prediction of the autism. So this is the development. I will show the mobile app. So you can see here we have used different deep and machine learning models for screening, and then we have a extracted the information, and then it's sent to the you can see a feature extraction. We have a questionnaire uploaded in a mobile app. We have a data processing in the cloud. We have a features extraction where a conventional and pooling. We are taking the mapping of all the data, whether it is relevant or not. Okay, so you can see here this is a mobile app. So patient is there from the sensors. We have a heartbeat, and these are connected with the firebox and decision making, and here we have a cloud interface, and we can have a fog as well. Then data collection will be done through video, audio, and quizzes. Quizzes in the sense questionnaire, and then we have a interface, phone interface, there we can collect the data, and then it will be sent to the next one. So these are the pulse sensor sensors we have. By using these different sensors, we can rest of the information, and then it will be sent to the by cloud and all. So this has been done by Python, and we use a Jupyter notebook, a Google server, and we use GPUs and TPUs up to 12 hours without cost, and then we are use some libraries. So this is the, you can see this is the app we have developed. Okay, so here you can see uh, the app, that is we have a different uploaded videos and uploaded audios and censored devices, and the survey we have done. So these all the data preparation has been done with the data pre-processing. Data will be splitted into three areas: validate data set, test data, and then we use machine learning model, and then prediction has been done based on all this all the criteria, four criteria. Okay, not only depends on only one say single criteria. We have chosen all the four criteria, and we have done wonderful job for rural community in Chhattisgarh state. So this is the one of the example. So you can see this is one of the uh, very good example we are working on it. Okay, so this is a develop a platform for managing management of SAM. That is this SAM. This is a survey acute malnutrition people in Chhattisgarh state. So these are the data we have so far. what we are doing, this framework is we have gathered the information by using different devices. Okay, the IoT devices develop a application. These are the sensors and communicated with the. You can see different officials. You can see here. Okay, management, transport management, national rehabilitation center, community management, and data management, welfare and child department. So this is the information. So these are data is gathered through the IoT devices, and these are the different criterias we have, and this data will send to the cloud, where we have a cloud platform. There we will send through the cloud all the directions. See here, various entities we have. Okay, here we have a communities, we have different entities. These all entities are connected with the cloud server, and it has been done with different gateways and all. So it will be this particular one is beneficial to the end users to reduce the lot of workers, and we have a patent, and other some papers, some children's in Chhattisgarh state. We have developed a software to provide the secure payment gateways for through this one. Okay, so this is one topic which we have work on different health issues, effective monitoring of system of different diseases, we can say, which involves which one is utilizing the help of cloud and fog and IoT edge devices, edge computing. So these all computing platforms are utilized in this particular examples. Next, come to the second talk is about how the blockchain is integrated with the IoT as well, as well with IoT as well as with fog and edge computing. So we have a yeah. This is one of the very good example where fog and cloud help taking care of. This is one of the very good example. These whatever I am talking about, all these are we have developed and developing projects. Okay, so you can see the food security in been a global issue. It's COVID-19. So around, if you see the food security in India, 71 first out of 113 countries, we need enough food sources and farming in the primary resources. So meanwhile, the global warming affects at the temperature and may increase it by 1.5 degrees Celsius in 2050. So, in a global pandemic crisis may occur for food because of the excellent quality and quantity of a crop production needed. So here the global warming issues that is there in nowadays in high temperature, floods and droughts. So due to this, we need a new next generation technology agriculture in fog and edge computing. So how? So you can see this is a figure where is where helps through by using fog servers and cloud servers. We are doing different leaf diseases and find out the prediction of the agriculture. Okay, so in this project we are used UAV with fog and edge computing for the two modules. Okay, so what we are doing here is we are deploying different in field as without field. And what we are doing here is we are taking the capturing the images from raw means there is no green field. We are capturing the soil testing information as well as we are capturing the greenfield information and through the drones, and we are sending this information. You can see here we have a different information here where pre-processing of this particular this is the rice, okay, seeds. So pre-processing and model load from the fog, from the fog, and different model, whether we will classify whether it's a ground spot or a different spot. And then we same time we are captured the different soil test, soil testing information. So we'll map these all things are captured from the different through drones, and these drones are connected with the fog edges, and then it will be sent to the data storage, virtual data centers, and management system. This is the monitoring of fog management system, and then these are connected with the cloud nodes, and we can predict the information for both. There is a lot of work we are doing on this particular. So you can see the IoTs day by day is started with 1992, and then it increased to 2020 50.1 billion data is extracted by 2020. And so these are the different applications are there in IoT, that is smart home, wearables, smart cities, smart grids, industrial internet, connected cars, connected health, smart retail, smart supply chain, smart farming. So even you can work on smart grids. Okay, so from smart grid you can deploy different sensing devices in a small these smart grid areas, and you can that also we are working on. We can collect the information how much of power is generated, and how much of which grid is not working, which grid is working. So these all the things is going on. So already we are working on smart farming as well as this supply chain, smart supply chain. So I will explain how smart supply chain is taking help of IoT and fog and cloud, and as well blockchain. So you can see here these are the different layers we have. We have a infrastructure, we have a network layer where can connect, and we have sensing layer, and we have application layer. So you can see different applications. So these all are work on control and optimization. Okay, so this is very good article. You can read it. Okay, then these are the different security aspects in IoT. So we have a physical attacks, we have a network attacks, we have a software attacks and data attacks. Okay, so you can see here in physical we have a different layer, perception layer. We have tempering, malicious code injection will be happen in perception layer. RF interface also or jamming also will take the fake node injection. Okay, so that is also as for example we have developed a we have a deployed different sensor in farming, and some injector or someone is came and they are inject a new node into the whatever the area you are having, whatever the nodes are connected. So if the fake node is injected in that area, again your problem will start. So then we have a sleep denial attack, side channel attack, then permanent DOS attack, and then in network we have in network layer these are different attacks we have, and traffic analysis attack, wormhole attack, RFID spoofing, and so these are the different attacks or in network layer. And then come to the software attacks. Software attacks we have a virus, worms, Trojan horn, spyware, and adware. These are the, and then we have a malware attack in the processing area. processing layer. Then data is inconsistency in network and processing area. Unauthorized access will be taken, can be done the attack. So in IoT security, we have a device authentication should be there, user authentication should be there, data authentication also should be there in industrial IoT or IIoT. Okay, so these are the different requirement preferences has been required for autonomous system. We have a faster transaction confirmation time and IoT, and we have a high throughput. It is less communication overhead. Then low memory requirement is then low communication complexity scalability. So how this blockchain or help in IoT as well as fog. So as you know, this blockchain is a distributed transaction layer with identical copy maintained on multiple computer system, which is controlled by different entities. So is working on properties of link in the data structure. Okay, so in data structure, what happened? We have a data and link. So this link is connected with the next node of next node, that is the data, and likewise it will be connected to all the nodes. Okay, so here in this sequence, if some data is missing or some node is injected or deleted from that link or that network, what happened? What happened? The entire system will be failed. Okay, so in that case, if someone is injected new node or in the existing node sequence, so there will be a possibility of a hacking of all the information. So to taking care of these things, okay, there is a centralized system, this a distributed ledger system, transaction ledger system, which help us to prevent the attacks and good accurate variable of records of each transactions. Okay, you can see here these are the basic diagram of blockchain structure, where we have a block version. We have a block version here. You can see a okay. You have a block of I minus one header, and this is the then difficulty targets. Okay, so this is the block header. Okay, same way, same time you can see this is the body of the block. So we can have, you can say this is the genesis of the block. Genesis of the means we can have parent of the block. So these are the block 1 2 3 up to I minus 1 and all. So from this you can see here, from this we have a splitted hash functions. So it will be splitted into this way, and then it will be communicated. So next, so you can see here, Bob wants to send the information to Robert. So there will be some transaction from Robert to Bob to Robert. There is a blocks TN to T1 to TN blocks. So these all transactions are added to the block and broadcast the block to the network. So this is the network. We have miners to check validity of proof of work solution. From this all the blocks where minus n solve the proof of work, then blockchain networks validate the all the blocks. Okay, so for example, we have a data. This data is across all nodes in the system. Okay, or if someone wants to communicate or send add the new data into the this existing blockchain network. So here what happened, the entire blocks will validate and authorize this particular block will be added to the existing system. So the based on the Genesis block, it will be validate and it will be added to the existing blocks to the network. So you can see we have a blocks here. You can see here we have a hash block. 0 times stamp is given, nonce is given, then is a marklet tree, tx12, txn. This is a Genesis Genesis block. From this block, marklet root. That root is you can see hash functions, different hash functions we have in a marklet tree, and then these are the I block of I minus 1 I, then this one. So the sorted chain is deleted from this. Suppose you want to delete this root block I from the network, then you should be aware and take the permission from the rest of the blocks minus, then only you can delete. So this is the history of blockchain. So blockchain started in 1990. 10, 2017, 20 people working on origin transaction contracts applications are using on. Okay, so you can see here blockchain 1.1, that is 1.0 is Bitcoin, then smart contracts 2.0, then decentralized applications in 3.0. Don't know what about 4.0. So we have a different network here, that is public, consortium, and private. Okay, so these are the networks which are you can see here these networks in public. Each network are connected with all the other networks. Okay, in consortium you can have a different entities and which communicate. You can see here this is not communicated with these two. So this network is communicated with these two networks. Similarly, in private, you can have a different entity people. These all are communicated with the this entity. So what is the help? What is the difference between this public, private, and consortium? And participation in consensus. In public, all nodes are participated in consensus mechanism. In private, single organization is connected with the consortium. Then consortium, selected nodes in multiple organization. Consortium means multiple organizations will be participated. So here in consortium, the consensus are selected nodes organization, and this will be uh, given in public, right, and but in private it can be restricted, and consortium it will be restricted. And then identity Sudoku anonymous, and here we have to take the approved participants in the private network, and similarly in consortium also. And immutability is good at public network. Okay, public blockchain is partially available in private and consortium. Okay, then transaction process speed, okay, which having slow in public and fast in both in private and consortium. Okay, so you can see this is the different gateways or as a endpoints to the blockchain. You can see here we have a different devices. This device are connected with the fog nodes. You can see these are the end devices. These end devices are connected with the fog node, and these fog nodes are connected with the this blockchain. As similarly, IoT device transaction issuer to the blockchain. So you have a different entities, and it will. So you can read this article. It's a very good application of blockchain in Internet of Things. So here you can see here interconnected edge devices as end points to the blockchain. So here you see all these connect all entities are connected with the blockchain, fog as well as the cloud. Okay, so people are talking blockchain in the sense only blockchain. I think there is no use of fog and cloud for the blockchain. So people are only working on fog things and simply on blockchain areas. But it's a very good the combination for research. You can work on it. So we have a good privacy for IoT security. We have a access control, data integrity, confidentiality, availability is there. Identity management also there in blockchain. Data management is also plays important role. IoT monetization is also there in blockchain based IoT. So if you see the distributed ledger platform here, there are two type of platform, that is general platform as well as a IoT focused platform. Okay, so in general platform we have a Bitcoin, Ethereum, Hyperledger. Okay, then you can see the in a general platform we have a Bitcoin and we have a Ethereum and Hyperledger. In Hyperledger you can see the Barrow, Fabric, Indy, Iroha, Satu. Okay, so work on two components in ledger, that we have worked on Hyperledger and we have worked on Hyperledger Satu. So while we are comparing these two platforms, we are very comfort and we got good result in Hyperledger Satu comparatively, that is Hyperledger Fabric. Okay, and come to the IoT focused platforms. You can see these are the different platform, machine to machine transaction platform, where we have IoT chain, IoTex, HDAC, then IoT data exchange platform, that Streamer. Then we have a identity management platform, autonomy. Then supply chain, we have a origin trial. Then smart grid platform, Grid Plus and Power Ledger. So these are the very good example for a smart grid platform. If you want, you can study this survey, that is distributed ledger technology to the IoT. AX published in ACM computing survey. We have a different platform. So these are the comparison of a distributed ledger platform for the application of IoT. Okay, so you can see here you have a Bitcoin platform, Ethereum, Hyperledger Fabric, ITA, IoT chain, IoTex, Streamer, and all these things are. Then we have a data structure. Which data structure these are you? Is used the blockchain. Ethereum also using blockchain. Fabric also using blockchain. IBM using the directed acyclic graph, DAG. Okay. Then iTex is multiple blockchain. So these are the different blockchain platform. And TPC, the performance, these are the good performance we have, and public ledger, and then smart contracts they are using, then currency, then consensus, which type of consensus mechanism are used in this particular platform. So here you can see Bitcoin proof of work launched in 2009. Okay, you can see here Ethereum is used switching from proof of work to proof of stake. Okay, similarly, these all are different consensus mechanism that use in different platforms. So this is also one of the very good example, the application of distributed ledger technology to the Internet of Things. So smart contracts is the storage trustworthy storage versus distributed trustworthy storage. So it is a virtual third party where we can execute and enforce the agreement. Okay, so this is the stateful and is having good. Okay, so you can see these are the different applications or layers are there. Okay, in IoT likewise, in here we have a perception layer, IoT blockchain layer, and application layer. So in perception layer, we have a different activators and sensors and storage, communication interface, and in a network layer, we have a network layer platform, that is routing management, network management, okay, broadband and Wi-Fi, uh, then security management. Then we have a IoT blockchain layer. Then here we have a network in between the protocols P2P and different components, big data analytics and all. And then we have a consensus manager and smart contracts and identity management here. So these are the network which is connected with each other. Then we have application, different application. We have healthcare data and then retail, smart cars and all. So this is a one ghost project where all connect devices are connected and all. So these are the so I'm skipping this. So this is one of very good. Sorry. These are very good example done by my scholar. Okay, that is this blockchain, IoT sensing devices, and fog layers and cloud layers are we have used physical ecosystem for identify the vaccine supply chain. So vaccine supply chain is the one of the application during COVID pandemic. Okay, so from the manufacturer to the end user, this the government of India is conducted pre conference or pre meeting about how this produce COVID-19 vaccines and how it is to the end users to the rural areas. So there is some constraint that we need to keep uh, these vaccines should be in a cold storage. Okay, so this cold store from we should be maintain proper cold system and temperature when it is manufactured from the factories to industry to the end user. Then only it will be inject to the patients or human being. If something happen, if the capacity or storage not stored in a cold storage area, then that vaccine will not be help for the vaccine this COVID-19 people. So these are the we need to these are the different challenges we have for this that is poor visibility, limited transparency, that how much they have done the proper maintenance of this particular COVID vaccine cold storage, then limitation in serialization, vaccine wastage and cold storage descriptions, and diversion of black market and counterfeiting. So during COVID, lot of vaccines are sold in black market. One vaccine is sold for 10,000, 20,000, 50,000 likewise. Okay, in initial stage. Later on, what happened is freely given by the government of India. Okay, so here we are using the help of IoT, and we have used with the help of blockchain. Uh, we used with the help of cloud and fog nodes. We have done the develop this system. So these smart contracts are implemented to automate generate the events and notifications in case of temperature valuation through the vaccine supply chain. Okay, so here the public blockchain are not scalable enough to implement this vaccine supply chain track and trace. So the cold storage integration. So here the plugged model of on-chain or off-chain data without modifying the existing ERP application for the better adoption and efficiency and lower cost. So existing system are not satisfactory in terms of performance and security. So here we have a developed, given the security resilience against the man in the middle attack, and also latency, throughput, and resource utilization for different databases we have compared with the level DP and couch DP databases here. So you can see here how this crowd is helps for vaccine supply chain. So you can see here we have a various virtual missions, and these virtual missions are allocated with a different distributor, different manufacturer, different reset, this retailer, and then different you can see here. So the virtual mission 2 having virtual wholesaler of CA2, 1, 2 and logistic and same wise likewise the virtual mission 3. So we have a this is a Dockers. These are the Dockers container which helps for track and trace. So these are the system. So we can have a node JS, we have a virtual machines, all the virtual machines. So manufacturer is connected, then wholesaler, retailer, distributor, and logistic. So these are the different we use hyperlaser fabric, cause DP and all. So here we have provide the evaluation. We have look into the security, confidentiality, lens, and then resiliency. Then integrity in the sense blockchain vaccine supply chain allows the user to track and trace and recording of vaccine circulation data and the temperature valuation on the chain which provide the data integrity. So whole complete data will be captured. Then confidentiality, if you see, it's a concern non-closure of vaccine circulation data and temperature. So as proposed system, we use a consortium blockchain in which only authenticated participant can have access of critical data for a particular session, right? Consortium blockchain is we can once you are giving the authentication, then only they can see or extract the information. Okay, so here when we are using consortium blockchain, so there is no chance of accessing data by the unauthorized pay participants. Therefore the confidentiality of the data is system is the preserved. Then we have a availability. So based on consortium blockchain, which is decentralized and distributed in nature. So here the guarantee that uh, just a minute. So it's a guarantee the party access the required requested data at any time because all the participants know recorded transaction and chain code logs. Okay, and even the in case of failure of the nodes at some point, the vaccine supply chain network cannot be stopped from the network. Okay, so it will be work. If some in some cases it will be failed, one node is failed, then rest of the node will be taken off entire system, then they will work. Resiliency is also, so this is the performance. I am skipping this one. So next one is we develop a consensus protocol which helps to transact the transaction quickly and efficiently using machine learning model. So here we are used new propose a new consensus model consensus model based on machine learning and game theory model. So it will be very much interested to work on. So this is the uh, methodology framework where we have proposed new blocks and form an n-player game, and these are help take the help of distributed table, and it will be check which block will be work on, and who is the winner and who is so we are using DP scan algorithm to density of clusters is found, and pointing representing the peer closest to the cluster central is the winner of the peers. Here we are having the peer-to-peer network. So the winner peer is calculated locally by all the peers and finally broadcast into the network. Then security penalties, the system resolve the geographical monopoly problem, considering the location of the peers and randomize them into the plane to minimize the selection of the lane within a geographical structure. So these are the different calculations, and we have these are the simulated parameter. Network size is 20. We have formed 20 nodes, 200 nodes, and the block size, each block say 1 MB, and the block time is 10 seconds has been given. Mining difficulty is 10. We have used a consensus algorithm, that is Minecraft and truly centralized system. So these two algorithms are verified on the network, and we have a attacker scenarios. Which type of attackers we have? We have a DDoS, Eclipse, and validated rings attacks, and it is a decentralized network topology, and so every second 500 transaction will be injected, and we have a malicious nodes 10 to 30% of nodes here. So this is performance block level, and then then attack defense, and then so next one is recommendation system, vaccine recommendation system with the blockchain, and then how it is useful. So vaccine recommendation system rises from the various challenges and opportunities in the field of public healthcare management. Okay, so which type of vaccine will be given to the end user? Okay, so here we have different components, which includes fragmentation of healthcare system, which helps with patient data stored in the cloud across the different institution or jurisdictions. So this can be difficult to say the data coordinator case, and we have a data security and privacy. So that is governing concern about the data security and privacy in healthcare system. So we are providing blockchain to secure a temper proof of method for storing and sharing the patient data, and ensuring the patient privacy is protected, and personalized healthcare. So it helps blockchain where we are vaccine supply chain recommendation system use RL, that is reinforcement mechanism, that when we analyze the patient data, provide the personalized vaccines recommendation based on the individual medical records, histories, other than other factors. Okay, so here we are providing the recommendation system that gives the benefit of security, transparency, and accuracy. So where this the entire data is stored into the cloud, which can be distributed manner, decentralized manner, and enhancing security with with enabling transparent traceable data sharing and across among the all the holders. So these are the different algorithms we have used here. Reinforcement algorithm we have used, and then we have developed that is smart contract automation process, such as vaccine procurement, distribution, and administration. This can be improve the efficiency, reduce cost, and minimize the risk of error or the fraud. So this is the database. Okay, so we have a different layers here. We have a user management layer. We have here EHR generation and view layer, storage layer, and access management layer. Okay, so you can see here all the different records, registration, key generated here, block generated, health generating view layer. This is the health provider. So this database, distributed database. This database is connected with the private blockchain. Then We have this recommendation system. Okay, this recommendation system take helps of the this blockchain, and it will be recommended which we can give. This is, we have a patient data, so this patient data will be access on these all the components, and then based on that the this entire system will give the preferences, okay, ranks to each vaccine. So this vaccine, based on the, if you insert the information of this particular patient, then immediately it will be help which type of vaccines will be given to that patient. Okay, so ranks will be given, and based on the history of the data, medical history of the data, it will be recommended this particular vaccine is more suitable for this patient. So we have taken the vaccine diverse event reporting system, and we have created the vaccine data set into the blockchain converter, and then identify the data set and defining the data structure, choosing with the blockchain plotting, creating the smart contract, and converting the data to the blockchain format, and connect to the blockchain network. Then we have a data access from blockchain secured vaccine dataset, which is identifying specific blockchain network, and which blocks that containing data, and extract the relevant transaction of the data, verify its integrity, and analyze the data to the make recommendation for the vaccine usage. So we have here feature optimization model. So this model will help. This model will. Okay. Then we have a sparrow correlation technique is used to correlation between two sets of things. So the next one is next component is the we have checked the vulnerabilities in a smart contracts composition in blockchain based vaccine supply chain, where by using fuzzy logic and patronate verifications. So these are the verifications. So here in the literature, many smart contracts, only single smart contracts formal verification has been done. But in the composition of numerous smart contracts is essential for you have we have a public blockchain with different layers and different distributed database, and for this database we each one we have a we written a smart contracts program. So in composition we need a secure transaction in supply chain based on the blockchain then. So the sustaining the integrity of vaccine supply chain management is depends on making sure that composite smart contracts are valid and secure. So, but very few work in the literature. There are work on composite smart contracts formal verification technique. So here the proposed system having some properties that traditionally have been verified methods like the traditional method petrinates and fine state mixtions and symbolic model checker like a new SMU or a different traditional behavior and properties verified systems. These are so the conventional methods might fall short accurate capturing ambiguities, emphasizing and dynamic nature. So blockchain composition of blockchain smart contracts and the blockchain based vaccine supply chain system is more precious and help to end user and all the companies which can use. So here use an approach that combining fuzzy logic as well as color patterns for formal verification and vulnerability analysis for smart contracts composition in the blockchain based vaccine supply chain. So here you can see the fuzzy logic is more flexible, realistic modeling of behavior, and then dynamic behavior smart contracts that allowing the uncertainty and impressive. So the color patterns are given a graphical as well as a formal framework for modeling and connections and interaction between the smart contracts. So here you can see this is a framework, and we have a fuzzy logic model, integration model, formal verification, vulnerability analysis. Then we have a color patterns model and the attack analysis. So these are the different analysis, fuzzy sets, fuzzy rules, linguistic variables we have for fuzzy logic, and then we have to check the places, transition, and tokens by using color patterns model, and we can have a attack analysis. We can analysis of simulation, impact the evaluation, and then we'll check the formal verification by using model checking and reachability analysis. So these are the different methods are used. So if you okay, so and T1, T2, T3, T4, any transaction. These are different transactions, and T R1, and these are the different transactions they are mapped with. So this is a verification by fuzzy logic and color patterns. So the simulation on these smart contracts, pattern and potential anomalies are detected. So you can see first we can define the properties and requirement, and then we can see the properties requirement is verified. Then if it is true or if it is verified, then go for the modeling of smart contracts. Then after that apply modeling of fuzzy logic, then modeling of color patterns, then check the whether the model is completed or not. If the model is completed, then again perform the formal verification. Okay, first we have to model the fuzzy logic for the smart contracts. We have to model the colored patterns for the given smart contract composition, and then if it is constructed and model the system, then perform the formal verification. So when you are verifying the formal verification, then if it is verified, then vulnerability analysis has been done. So vulnerabilities are found, then we have to check the verification, the developer countermeasures, and then if it is not, then verification successful. Then again it will be back to the vaccination. Whether vaccination is failed, then back to the model is incomplete. Then this all complete system is if it is not true, then it will be the properties in requirement is not defined, and then add on some properties and then continue with. So we have you can see here we have a different these are the examples. We have a attack, smart contrast, verification, vaccine. So here you can see what are the entities we have. Here you can see in the example we have a manufacturer here, we have a logistics, distributor, and healthcare providers, and smart contracts to processes, that is order creation, vaccination is verification, shipment tracking, payment verification. So these are the different processes. Then we have a potential attack scenarios, that is what are the potential attacks we have, that is counterfeit vaccines. Okay, and then we have a classifying temperature logs. So whether the temperature is there, or the cold storage, whether it is there or not. Then we have an unauthorized data access, that is AS3. Then we have a some variables. Okay, so based on that, you can see CPN model here places order creation, quality verification, shipment, payment, transactions, vaccines, shipment, confirm, confirm payment, and we have a that different batches, different vaccines. So you can see this is a vulnerability analysis. Okay, on this given supply chain. So you can see here, these are the experimental studies that what are the possible participants. That is 50. So we have first we have considered 10, then we have considered 50, then we have considered 100. Okay, likewise we have, and we have a different transaction volumes at the low, medium, high. Okay, then we are used here different consensus protocol, that is proof of work, proof of stake, then that is a PBFT, that is budget and fault tolerance, and delegated proof of stake. These are the and raft consensus protocol. So we have tested on these different protocols, consensus protocol for this fuzzy logic colored pattern nets. Okay, then we are checked with the composition, that is smart context use, that is the order placement, inventory management, payment processing. So these are the different composition components. Okay, then we have checked the different attacks. This type of attack is then DOS, data manipulation, unauthorized access will be done or not, DOS, attack, and inside attack. So these are all attacks are verified in composition, smart contracts composition things. Then attack intensity network. So what are the network topology we have used? Centralized topology, decentralized topology, and hybrid. Both topology we have constructed, and we have verified this particular verification for different these three different network topology. Then which type of communication protocol we have used for this that is MQTT, HTTP, and WebSocket are used. And then we have a parameter, that is transaction timeline, timeout, and resource allocation and all. So that is a one work, and this is a vaccine recommendation system for vaccines by using various machine learning model. So during COVID-19, we have done work. We used Pfizer, and then then other two vaccines, that is Oxford COVID-19 vaccines, then AD26 developed Johnson and Johnson. So here in this model we have used proposed a vaccine recommendation system that is considered. You can see here we different point for the patient. The patient records that sex, medical history, allergies of the host, and heart rate and recovery rate, death rate after vaccination, symptoms, vaccine to be make utilized. So we are used score-based method utilizing machine learning model. So this is our framework, and in this framework we have three modules, that is input module and data processing module, vaccine recommendation system module. So this data process, so this entire data set is stored in the fog network, and we have extracted the information, and the whatever the this particular machine learning, whatever the machine learning model, whatever these all are deployed in the fog devices, and then we use these models that is data processing, feature extraction, reconstructing of the data, removing the missing values, and then data measuring models, that is a TFD, counter vectors, logistic regression, then scoring models we have used, scored Boolean algebras, scored textual features. So these are the different methods we have used, and the system is helps. Okay, helps which type of vaccination is good for. Okay, so see methodology and this we have taken. Okay, then when we are performing the experiments for given data. Okay, so that time we don't have. So we have collected from the cloud, the from the different platforms, and we store it into the cloud. And then when we are using, so we for experiment one, this is the age, this particular age, this is the male, and we can recommend Janssen is the vaccination. So for this particular person, we can have. Uh, then then we have a second experiment. We have a Moderna. Then we have a Johnson. Then for the experiment four, the age that is 52 and sex is female, and Johnson is good for his health, her health. And then next one is for experiment five. You can see the age is 32, the male person, and what is the history? History is that I have problem with the penicillin. Also, I usually have high headache and mild fever. Then this is the history, medical history of the patient. So, which type of vaccination is recommended? Johnson is recommended for this particular end user. So, similarly, you can see other age factors, other experiment. Similarly, these are the evaluation, and these are the different scores has been given to different Pfizer, Moderna, and Johnson. So these are the different experiments. So likewise, if you given some data and inputs for this particular patient, which type of vaccination is good. So during COVID, initially these three vaccination is came into the picture. That's why we considered these three vaccination, and we have worked on it, and we got success in this one. Later on, Covishield and Covaxins came into the picture. So, so this is the another for another disease that the flu 3 vaccination for different kind of experiments. So these are the you can see these are the vaccines, Novartis vaccines and diagnostics. You can see these are the different vaccines, and these are the different if the people are having some health problem that then they will recommend different vaccinations. So these are the performance level, and thank you. If any query, please let me know.